What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. So, in this video, we will be discussing, part 12 of our MatPlotLib tutorial series. You guys know we have been working with a data visualization with Python tutorial series. So, I'd like to mention, guys, that this is the last video in the data visualization with Python tutorial series. Within this video, we will just conclude by rounding up some annotations that we have to, talk about. And yeah, that will be mostly it. Nothing too difficult. This will be a relatively short and quick video that we go through. So that's fine. So first things first, what I'd like to show you, right, is you guys know that we have just spoken about ticks, right? Ticks in the previous video. Essentially, we know that these ticks are kind of markings on the axis themselves that help us to get a better understanding and insight as to what the data is about, especially when it comes to giving us more control over the values, especially if they are numerical values. Ticks make it easier for us to kind of work with the canvas itself. So what I'd like to mention, right, is oftentimes when we have a bar plot, okay, in certain situations you may require the bar plot to have some sort of markings on it. So what I'd just like to show you now is how you have the ability to actually set ticks, okay, to be equal to the bar itself. So if that makes sense, that is all good and fine. If that did not make sense, please don't stress about it, because we are going to I'm going to show you an example now. Okay, so essentially what you need to understand is what we are doing is we are creating a bar chart that has fixed labels as in those values that are showing up on the x axis. So we are giving a label to the tick itself. Where the marking appears on the axis, below that marking will be the label. So think of it as such, where the label is bound to a tick. So yeah, that's a good way to put it. So let's get to it, guys. First things first, I'd like you guys to import numpy as np, import numpy as np, import matplotlib dot pyplot as plt. So those are the standard importations we've been working through for the entire tutorial series. So what I'd like to do now is I need to set or have a name list. Now the name list, you guys can make it a tuple or a list, anything you'd like to make it. I'm gonna go with tuple. So what I'd like to just explain is the name list is going to be the actual labels that are going to show up on the x-axis. So these are going to be the labels that show up on the x-axis. So suppose we have names of people, and just to give you a bit of context here, suppose we are plotting student name and the mark that they obtained. So just to give you perspective, the bar itself, the x-axis labels, will be the names of the students, and the height of the bar can be the mark that they received. So that's fine, just to give it a bit of perspective. So these are names that I am coming up with. Suppose we have Max, we can have Zoe, as well as Edibin. So that's the name list. Now we need another list. This will be the value list. I can set this to a numpy dot random dot randint, and within this I can say 0, 99, size is equals to the length of the name list. This makes sense, guys, because we want the same number of values to be generated as there are labels on the x-axis. For each x-axis label, we'd like to have a corresponding y value, which is basically depicting or denoting the height of that bar itself. Now I will set another list. Call this position list. This will be numpy dot a range, and within this the length of the name list. So all of these methods are ones that we've covered before several times, including the a range function. So I'm not going to explain much there. What we will do next is plt.bar. This is the bar plot. We will pass the x values, which, as you know, x values for this, what we need to pass is position list, or actually name list. We will pass value list. We will pass color, and we will pass, so suppose color is a gray color string, I will pass a line is equals to center plt.x ticks. So this is where we set labels for the ticks themselves. What you want to do here is pass the position list. So guys, I just see now as I am typing that I've actually made a slight error. Okay, in the bar plot itself, for the x values, do not pass the name list. Okay, pass the position list, the numbers only pass the numbers. So position list. Now the reason why we're doing that is because, think about it, right? What's the point of passing the names to the x-axis for the bar function when our goal now is to tie a name to the tick itself? So this is the point at which we do this. plt.xtick, we are tying the position, the respective position, with the name list itself, the name. Okay, so each respective name in the name list, which is this here, is going to take on the appropriate respective position that we have in the position list. So I hope that makes sense to you. So finally we do plt.show, and now when I run this, as you guys are going to see, we obtain the following output. So as you run the script, the bars themselves will differ in height because of the fact, you know, that we are generating random heights. So go ahead, experiment with this, play around with this. As you can see, the ticks are fixed. Okay, the ticks themselves are bound, or it's better to say that the names, the x-axis labels, are bound to the ticks themselves. Okay, so that is interesting to know. Now this is extra information for you. It's not necessary for you to know this. You can end the video here, but if you are curious and you just like to expand your knowledge base, this, now what I'm going to show you is how we have the ability to do advanced label generation. When we talk about labels with regards to the bar plot, we are talking about the values that appear on the x-axis. We call them labels because they have the ability to be either numbers or strings. As in the case we observed, we did not set the x-axis to have values, integers, we set it to have strings. So that's fine. Now, this is me demonstrating for you how we can do advanced label generation. So import numpy as np, import matplotlib dot pyplot as plt, import matplotlib dot ticker as ticker. So those are the three importations that we are going to use for this example. Now what I'll do is define make label. I will have value and position. This function will return a string, a formatted string, so 0.1f. This is something we learned in our NumPy tutorial series. We learned how to format our strings with regards to numbers. So this is exactly why and how you can see NumPy, SciPy, Matplotlib, they all work together, especially when it comes to handling your data. they work together, including another package that I have not put a tutorial up on the channel as yet. It's called pandas, and I am going to actually, create a tutorial for this. But all of those packages, including pandas, they work together to help us process and just get insight into our data. We refer to the entire concept as EDA, in case you are wondering. EDA, you may ask what it stands for. It stands for exploratory, let me spell this correctly, exploratory data analysis. That's what it stands for. Okay, so EDA. Anyway, coming back to the main point, x is equals to plt.axes. This is us creating the axis of the canvas themselves, or the plot itself. Now what we need to do is x.x axis dot set major formatter, and within this I will do ticker dot func formatter. Within this I will say make label. So everything here is pretty much built into Python. The only thing you need to understand is that when you are using this piece of code, the make label itself is a function that you will have to define. Okay, so you can change this function to kind of output a string, any string that you like. Okay, and it will do that for you. So what you would like to do next is to actually generate some dummy data for the x axis as well as the y axis. So what we can do is a simple numpy.linspace, as we've been doing all along. We'll do 0 1 256. Now what we can do is, instead of setting an explicit y value, what we can do is plt.plot. So this is us working with a line plot. So let me demonstrate for you. Now plt.plot, let's say we have x. For y value, we can just set that to be numpy exponent -10 multiplied by x. Color, let's keep the color standard, guys. Make it a black. plt.plot, another graph this is. X will do the y values as numpy.xp, which is basically exponent. We'll do -5 to the power, or more like multiplied by x. Color, keep it a standard black, guys. Will be simple in this specific demonstration. One more thing that I'd like to do is ls. I am deliberately using ls because I want you guys to become acquainted to using the short form of the parameters. Do not type out line style. I mean, you can, but in actual sense, a good programmer is a lazy programmer. So just use the shorthand, it will save you time. So that's what we have now. Now when I run the script, I want you to pay attention to the x-axis labels. Okay, this is called advanced label generation. Okay, and as you can see, this graph itself is one that is pretty, I would say, high quality, high level, because of the fact that it contains such x-axis labels. Okay, so that is how we generate fancy X labels. So I mean, there are several more possibilities that you have for fancy labels or advanced labels. I would like to demonstrate one more for you, and after this we will conclude this video and the tutorial series itself. So I do hope you guys are enjoying this tutorial series so far. So go ahead, do the same importations as we did before, and I want you guys to add one more importation, which is import DateTime. It's a built-in Python package, so you guys don't have to stress about installations and so on. Now what we are going to do is start date is equals to DateTime.DateTime. I will not be explaining the DateTime portions of code, guys, because that is a whole other package, and this here is just extra information for you to take away. So define make label, it's the exact same procedure, right? Value position. What this function is going to do is time is equals to start date plus date time dot time delta. Within this, I'll say days is equals to 365 multiplied by value. I will do here return time dot string format time. Within this, in a string quotations, I will say %b %y. Now that's all that's being returned by this label function. Okay, the procedure is exactly the same as we did before. Okay, for the rest of the code, it is now time to actually set up an axis for us. Plt dot axis. Within this, x dot x axis, you guys can actually copy paste the code from previous. I see no reason why you cannot. Okay, so I'm just typing it out because as you type out things, you just get better at it. So make label. Let me remove this. So that's what we have here. Now it is time for x is equals to numpy dot linspace 0 1 2 5 6. Let's plot, guys. So plt dot plot. For the y values, what we can do is exactly the same as before, right? Exp within this -10 multiplied by x. Color, let's keep it simple, black. You guys can be fancy if you'd like to. Set it to any color that you feel you require. So again, -5 multiplied by x. Color is equals to black. Let's do line style is equals to a dashed line style. Now what I'd like to do, labels is equals to x dot get x tick labels. Within this, plt dot set p labels rotation is equals to 30. Plt dot show. If some of the lines of code don't make sense, please do not stress, guys. I will give you a brief rundown afterwards. So let's actually run this, and as you guys can see, this is what we are outputted with. Okay, this is another demonstration, an example of how you can use advanced label generation, to make your MatPlotLib plots really stand out. So essentially what we did is, the only different importation we had was DateTime. This is a package built into Python that is used for handling, as implied by the name, dates and times. So we have this datetime.datetime. We've defined our make label function that's actually going to return the labels for our plot. We have set up an axis, the x and the y axes that we will use. We set the major formatter to be the labels that we create for the x axis. Now x, this is simple, that's us generating our x data. Plt.plot, that's standard. Now labels is equals to x.get x tick labels. This is basically getting the labels that are going to be stored on the canvas themselves, specifically now pertaining to the x axis, because it says x tick labels. Then essentially what we did is we took those labels that were stored in an object and we explicitly made those labels angled at a degree of 30 degrees, which accounts for the slight tilt that we see the x labels take on in the plot. And finally we called plt.show, which returns to us the completed visualization. So that is all for this example and for this video. So guys, with that, we've successfully completed another tutorial series on the channel which deals with data visualization with Python. So I really hope you guys are having as much fun following along and learning as I am making the tutorials for us. So If you are enjoying the content on the channel so far, do make sure to give a like for this video, subscribe to my channel. The greatest way in which you can support me is by subscribing to my channel. So thanks guys. With that, good luck with your work and I will see you in the next YouTube video.